Dear students, so today let us we study about the topic nuclear chemistry and the nuclear particles. In the fourth semester, you have a new branch of chemistry called the nuclear chemistry, which deals with the following points: the nuclear particles, and in that nuclear particles you are going to study about the positron, neutrino, mesons, pions and quarks, nuclear instability, problems on mass defect, binding energy, decay constant and half-life period. You are going to study about the nuclear reactions like alpha N, N alpha, alpha P, P alpha, so Pn and Np reactions. The liquid drop model of nuclear fission, nuclear reactor and types of nuclear reactors in India. We are also going to study on nuclear fusion, uses of radioisotopes in tracer technique, agriculture, medicine, food preservation and carbon dating, and also the problems on carbon dating, which carries 8 hours. Now let us know what is this nuclear chemistry is. Nuclear chemistry is the branch of chemistry that deals with the study of structure of nuclear forces holding the nucleons together, radioactivity, both natural and artificial, nuclear transmutation and their applications. Let us study today about the nuclear particles. The nucleus of an atom has different types of particles in it. The charge, mass and spin are the most important properties of these particles. Each of these particles is represented by a symbol. The mass and charge are denoted respectively as superscripts and subscripts to the symbol of the particle. Suppose if I write the helium, we write helium He24. The 2 signifies the charge and 4 signifies the mass. The mass of the particle is in terms of AMU, that is atomic mass unit. The spins of the particle is represented either plus half or minus half. Now, Rutherford discovered the proton. It carries unit positive charge and has rest mass 1.00762 AMU. Its spin is plus half. It is considered as hydrogen ion. It is represented as either H or P. The symbolic representation is H plus 1 1 or P plus 1 1. Plus 1 signifies the charge of the proton and 1 signifies the mass of the proton. Coming to the next nuclear particle, that is neutron. James Chadwick in 1932 discovered neutron. It carries no charge, that is neutral, and has rest mass 1.00861 AMU. Its spin is plus half. Its mass is slightly greater than that of a proton. Unlike electrons and protons, neutrons are not capable of independent existence outside the nucleus. It has a short half-life of 12.8 minutes and decays into a proton and an electron. It is denoted as the neutron having a charge 0, 1, 0 and mass 1. It turns into proton in the nucleus and gives out electron. The antiparticles. In 1930, PAM Dirac put forth anti-particle theory for the fundamental particles. At that time, this concept was criticized by other theoretical physicists. According to Dirac, he says there is a presence of anti-electron, anti-proton and anti-neutrons. Now coming to the anti-electron, or it is also called a proton, it is also called a positron. In 1932, the first antiparticle called anti-electron or positron was discovered by Anderson and Caltech during studies on cosmic rays. Positron has the 1 unit positive charge and has the same mass as that of the electron, that is 0.00055 AMU with the spin plus half. It is represented as E plus 1 and mass 0, or a beta having a plus 1 charge and mass 0. Positron has a short existence of 10 raised to minus 10 second until it meets an electron. Annihilation of both particles occurs and 2 gamma ray photons produced. The total energy of these 2 gamma ray photons is equal to the energy equivalent of mass of destroyed. That is, according to the Einstein's theory, E is equal to mc square. That is, the 2 electron and anti-electron, that is called the positron, both combines to form the 2 photons of, that is the gamma ray photons. Positron is emitted when magnesium 23 decaying into sodium 23. The reaction is the magnesium 1223 turns to sodium 1123 and gives a positron of mass 0, charge plus 1. Similarly, let us study about anti-proton. In 1955, C. Gray and his co-workers from California University produced anti-protons by bombarding a copper target with highly accelerated protons, that is greater than 6 billion electron volts. The antiproton has the same mass, that is 1.00762 AMU, and spin plus half as that of the proton and has unit negative charge. It is represented as the P charge minus 1 mass 1. Similarly, let us know about anti-neutron. Cork and his co-workers discovered anti-neutron. It is neutral with the same mass, that is 1.00861 AMU, as that of the neutron, but with opposite spin, that is minus half. Now let us know about the another nuclear particle, that is neutrino. A free neutron rapidly decays into a proton and an electron. During such a decay, there is a loss of mass equivalent to that of 1.5 electrons. This loss of mass does not appear as kinetic energy of the emitted particles. Pauli in 1927 suggested the existence of a new particles, neutrino, in such decay. Neutrino is a particle of 0 charge and of a variable mass less than that of an electron. It is denoted as mu. The existence of neutrino was demonstrated by Allen and Rhodback in 1932. So, if you take a proton, that is H11, turns into the neutron having a 0 charge and mass 1 and giving a positron, that is the E having a charge plus 1 0, and during this neutrino is emitted. We also have anti-neutrino. In 1934, Fermi indicated the existence of anti-neutrino. It is a particle identical to neutrino but with opposite spin. It is denoted as mu bar. It is emitted during electron emission. So when you take a neutron, neutron turns into the proton, and during this electron is emitted, and during this reaction anti-neutrino is emitted. The spin of neutrino is plus half and anti-neutrino is minus half. Coming to the particle called mesons. In 1936, H. Yukawa suggested the existence of a particle which creates an attractive force between proton and neutron in the nucleus. In Greek, the word meso means middle. Meson is an unstable particle with a mass intermediate between that of an electron and a proton, which binds nucleons together. In 1937, Anderson and Niedermayer confirmed the existence of such a particle through cosmic ray studies. There are three kinds of mesons, namely mu meson, pi meson, and k meson. Mu meson is a particle with a mass 206 times that of an electron carrying unit positive or negative charge with plus half spin. Pi meson is a particle with a mass 270 times that of an electron carrying unit positive or negative charge or even zero charge with zero spin. The pi meson decays to mu meson. The half-life period of pi meson is 2 into 10 raised to minus 8 seconds. K meson is a particle with a mass 970 times that of an electron carrying unit positive or negative charge or even zero charge with zero spin. It has the half-life period of 1.2 into 10 raised to minus 8 seconds. Coming to the another nuclear particle called quarks. A quark is a type of an elementary particle and a fundamental constituent of matter. Quarks combine to form composite particles called hadrons, the most stable of which are protons and neutrons. The compound of an atomic nuclei. The existence of quarks were confirmed by Murrow-Gell-Mann in 1964. Quarks have not been directly observed or isolated. There are 6 types of quarks, namely up quark, down quark, strange quark, charm quark, bottom quark, and top quark, known as flavors. The up, charm, and top flavors carry a positive charge equal in magnitude to 2/3 that of the electron, that is 2 by 3 times the electron, and down strange and bottom flavors or the quarks carry a negative charge equal in magnitude to 1/3 that of the electron, that is minus 1 by 3e. These two groups are also called as up quarks with charge plus 2 by 3e and the down quarks with charge minus 1 by 3e. The quarks have a spin angular momentum of 1/2 unit of h, that is h upon 2, where h is the Planck's constant. Quarks and electrons are the smallest things known as fundamental particles. Quarks and electrons combine to make atoms. Quarks combine to form protons and neutrons. Each proton and each neutron contains 3 quarks. Quark is a fast-moving point of energy. Antiparticles of quarks are called antiquarks. There are 6 antiquarks denoted by a bar over the symbol for the corresponding quark. Up antiquarks is given as U bar, similarly the C bar and T bar. The down antiquarks are also given as D bar, S bar and H bar. Antiquarks have the same mass, means lifetime and spin of their respective quarks, but they have difference in electric charge. Quarks and antiquarks combine to form mesons. One example of a meson is a pion, which is made up of an up quark and a down antiquark. Antipion is made up of a down quark and an up antiquark. Pions are also called pi mesons. K mesons are also called kaons. Kaon is made up of one up quark and a strange antiquark. Mesons are extremely unstable. Proton is formed by 2 up quarks and 1 down quark. And here the spin of the proton is given as the plus half, minus half gives rise to plus half. Sorry, the minus half, plus half, minus half gives rise to the minus half. Charge of this is plus 2 by 3 plus 2 by 3 minus 1 by 3 gives 1. Similarly, the neutrons, so the neutron is formed by 1 up quark and 2 down quarks. Here the spin is minus half plus half gives rise to plus half. Charge is plus 2 by 3 minus 1 by 3 minus 1 by 3 gives 0. So it means from here what we have understood is the atom contains the fundamental particles, that is the nucleus and the electrons. The nucleus carries protons and neutrons, and these protons and neutrons contains quarks. It is just like if you consider the cell of either a plant or an animal. So each cell contains the cytoplasm and then the nucleus. So in the cytoplasm means here the electrons are spinning, rotating, revolving around the nucleus like cytoplasm, and the nucleus contains the chromosomes. These chromosomes are nothing but here like protons, neutrons. Chromosomes contains the genes. Here the genes are nothing but the quarks. So this is how we can compare the atomic structure with the SL. This particular slide shows the constituents of the atom. Here, as I have said, so they contains the leptons. The leptons are present in the electrons and quarks are present in the nucleus. So there are totally we have the 6 quarks and 6 leptons. Now these are also known as fermions. Surrounding the nucleus, we have a space, that is a strong force that binds all the particles, or the force that binds in the nucleus are of 3 types. One is weak force, another is electromagnetic force, and third one is the strong force which binds the nucleons together. So the strong force which binds the nucleons together is called the gluon, and the electromagnetic force that binds the nucleons is known as photon, and the weak force that binds the nucleons is called the bosons. In the bosons we have W boson and the Z boson. Okay, and then we also have some particles inside the nucleons. They are known as Higgs particles. So this is the slide. It clearly gives whatever we have studied so far about the nuclear particles. So this slide also explains the same thing in detail, and go through this particular slide and you will come to know whatever the discussed so far, it is present there. Here I have shown the hadrons, mesons. So the quark and anti-quark together, it forms the mesons. Okay, as I have discussed, like the neutral kaons, positively charged pions, and the neutron contain, so the 2 down quarks and 1 up quark, and proton contain the 2 up quarks and 1 down quarks. Similarly, we have anti-neutrons and anti-protons also, so which contains the 2 anti-down quarks and 1 anti-up quark, and then the proton contains the anti-up quark, anti-down quark, and anti-up quark. This is a slide what I have explained just now. In this slide, I have shown the matter. This matter, it contains the fundamental particles and the molecules, and molecules contains the atoms. Atom contains the electron and nucleus. The nucleus contains protons and neutrons, and these protons and neutrons contains the quarks. The quarks combines to form the mesons, and like this, the things. Earlier we thought neutron, protons and electrons are the only fundamental particles, but today we have discovered the protons and neutrons. Still it further contains the quarks. So the below slide also explains the same thing. So this is a diagram showing how the protons and neutrons, they contains the quarks. And here the below, the protons and neutrons, what is the spin of the proton and what is the charge of the proton. So we have studied the spin of the proton and neutron is half, and the charge of the proton is +1, and the charge of the neutron is 0. how we get this charge and the spin. So this we get from this slide. Proton contains the 2 up quarks and 1 down quark. So the spin of the proton is given as 2 up quarks have the positive spin, the plus half, and the down quark is having a negative spin, that is minus half. So total it gives the plus half. Similarly, the charge of the proton is the up quarks, they have the what you can say the charge plus 2 by 3 plus 2 by 3, and the down quark is having a charge minus 1 by 3, so that is equal to plus 1. Similarly, for the neutron, the spin is, it contains the 2 down quarks and 1 up quark. The down quarks have the spin, the plus half, and the up quark is having a spin minus half. So therefore minus half plus half gives rise to the plus half, and the charge here is plus 2 by 3 minus 1 by 3 minus 1 by 3 gives 0. This is how the charge is given to the protons and neutrons. So this is about the fundamental particles and the what you can say the nuclear particles. So thank you, students.